Welcome to part 2 of this lecture, and we're going to talk about user experience and user interface design. From the science fiction stories that we all hear from our childhood to the augmented reality phenomenon that has turned into the technology that is actually super real, which finds its application in almost everyday life situation, it's important to think how we use it and how we deliver this message. Since we live in 3D environment, and augmented reality basically provides an opportunity to create digital 3D environments, let's discuss how we can use all these capabilities of augmented reality medium. The first question you need to ask yourself is, do I have a spatial problem? By this I mean whether the augmented reality is the best solution for your problem. Maybe you need just a simple mobile application or a PowerPoint presentation maybe. Augmented reality can help to bring the outside world into the inside. From a virtual safari, for example, with 3D animals in your living room, using Google Augmented Reality search that you probably have tried already on your smartphone, to collaborating with different avatars, with remote colleagues, using the application called Spatial. They recently released a video about this. There are actually three things that augmented reality does very well: visualization, annotation, and storytelling. These are the examples in each of the areas that are both really timely in the current reality, and we will go and learn more about them now. So the first one is visualization. Augmented reality is a very powerful visualization tool, and probably this is the most popular and the most common example that you came across. It's basically a process of showing an invisible. For example, on this image you can see how the Magic Leap implemented in collaboration with the Brain Lab, a brain visualization. So it's something hidden inside our brain, something that we can't see and probably touch and see real size and rotate and move and disassemble maybe at some point to see what's inside. So to show hidden, to show invisible. This use case is very popular during different classes, in educational context mainly. The second one is annotation. Annotation as when you try to help someone to complete the task, navigate someone through the environment that is really hard to understand. For example, London National Theatre is using augmented reality to help make its performances more accessible for people who are deaf or hard or have difficulties hearing. So when wearing a pair of smart glasses, they can see a transcript of the dialogue and the descriptions of the sound from a performance displayed on the lenses. So different cultural institutions around the world are trying to present live streaming content before closing. So this is one of the ways of sharing hidden information, helping to annotate information that is not accessible to everyday users. And the last one is storytelling. So augmented reality created this new mode of storytelling, and during this course there is a special lecture on storytelling as well. You will learn more on storytelling during that lecture, but this is also one of the common use cases when AR is used to tell stories, share creative expressions and experiences. For example, this lesson in history using augmented reality to help rewrite history books in the classroom and inspire the leaders of tomorrow by featuring different stories of powerful women. You can use your smartphone to scan over any portrait of a man in a school book, for example, a history of the United States, and you can unlock a special related story about that forgotten person in history, and you can learn more about this. And also you can enjoy this story basically anywhere, since augmented reality application will be working even without a textbook. So you can either have a physical book and read an overlay, or you have no book and just having digital version of it and exploring only augmented reality content. So it's basically enhancing. It's similar to annotation, but in this case you can have more imagination. So your story is not limited to only what's happening in real world, but you can tell some sort of hidden and untold stories. AR interfaces provide excellent opportunities for improving user experience, and we will see now how visualization, annotation, and storytelling can be used in real-life scenarios. And to see why, let's consider an airplane mechanic who walks around the inside and outsides of the aircraft for an inspection reasons, for example, and needs to check for how long a certain part has been in service. So with traditional screen-based user interfaces, the mechanic would have to somehow save the part number and remember it in their head, taking a picture on the smartphone or writing it on a piece of paper somewhere, and then access a phone or computer-based system to determine for how long that part has been in operation. But with augmented reality, for example, using HoloLens or Google Glass, the service records basically what is in use, and the service can display right on top of the item with a little or no commands from the user the final result. So we can easily see this action happening. And in this case, augmented reality can help the user experience in three fundamental ways. The first way is the end goal, the task. So basically, by decreasing the interaction cost to perform a task, augmented reality helps to save mental and physical efforts that users are spending on the system. The interaction time is much more efficient, and as a result, the user reaches his goal much faster. So the second fundamental way is the cognitive load. The cognitive load imposed by a user interface is an unimaginable amount of mental resources that people spend on the system. And by reducing the cognitive load, we can help them to use the system quicker. And the third way, AR can help user experience by combining multiple sources of information and minimize attention switches. For example, with non-augmented reality system, if the mechanic wanted to save the part number and use a different system to find its history, for example, he would have to switch attention from the plane to that external source of information, providing the part's age, for example. But with augmented reality, the two sources of information are combined because the relevant information is displayed in that overlay on top of the part itself, so the mechanic won't need to divide attention. So it's helping to minimize this attention switch. And many complex tasks such as surgery or reports, they involve putting together these multiple sources of information. So definitely some of them will benefit from AR. And augmented reality itself as an additional user experience is actually minimizing these attention switches. Let's talk about the process of how we start designing this experience and applications from the user experience and user interface point of view. Imagine you have a team or you're working on your own and you need to start working on the project. You have an idea in mind, but you don't know where to start. So if you're working with a team, the first step will be onboarding. Basically, you will start with finding a user experience designer who can conduct interviews with different stakeholders, different user groups, and the person basically who studies the technology, all its aspects, and works on initial concept of the experience. So user experience designer is someone who is working with users and with stakeholders all the time. It's an iterative process. You cannot really stop doing this at any stage. But during the onboarding, that's where you start. You start from learning who your users are. The second step is product and user analysis. We will learn for whom this product is created and how often it's going to be used, what is the environment of use, and what needs actually these users have and how we can help them. This happens using different methods, and in our last section today, the methodology section, we will cover these aspects. How do we collect these requirements? How do we speak with the user? How do we find the best method? But this is the second point where you need to explore this further. You analyze, you design, you analyze, and you design. And design is actually step 3. It's called information architecture. It's where you create the first design prototype, the first basically scheme. It's like the slides in a photo album. So all the scenes, all the environments, and all the screens of your experience, basically everything that you have in your head, you need to put on paper, or augmented reality scene, or for example, 3D prototyping environments. This will help to create the more flexible environment that you can later change. If you go to step 2, where you're learning from your users, you can show them this prototype and easily change it. So you cannot really skip the step, because you need to have an initial information architecture of your project. And after you change it, you can go to step 4, which is prototype. Prototyping is the stage where you create the first either high fidelity or low fidelity, depending on your needs, prototype. And this prototype is considering the users, all the requirements that you collected, all the technological specifications that you gathered, and this prototype should show the basic functionality of this product. It's basically something like a demo, but very advanced demo. So it needs to be functional, it needs to be really representative of your goals and all the functionality that you have. The next one is step 5. It's called visual design. It's basically where you start implementing different UI practices. It's suggested that you follow and reference the best UI practices that are out there in the design world of augmented reality, and you need to make sure that you test your experience with end users. And ask yourself questions like, is your design accessible? Is it easy to use, actually? So try to follow the well-established design guidelines that are published by different AR corporations, such as Microsoft Design Guidelines or ARKit Design Guidelines, that guarantee that across all platforms and across all users, your content will be understandable, representable, and well used. This also helps to create a healthy environment where different designers from different countries, they know what to use, how to use. This helps to make the process more transferable and basically easy to interpret and work with. So I highly suggest you to follow the design guidelines. Step 6 is the actual development. So that's the process where the handoff is happening, the design-developer handoff. The development process is always the last step, so as you know. So after all the designs are frozen, you can easily say, okay, let's develop it completely, ideally. And always tell your developers to document the code, so you can also, if you have an experience in coding, you can interpret the comments, you can easily change something, for example, the speed of movement of the hologram, the size of the hologram, the position of the hologram. So it really helps to simplify this process. As I mentioned before, it's important to reference existing user experience and user interface guidelines, as this will help you to build applications that have common interaction bases and are easily understandable and accessible by different people. Referencing guidelines creates a design and development culture across AR creators from different countries and cultures, and that speeds up the adoption of augmented reality medium itself. During the last couple of years, augmented reality tech giants have released these guidelines that are designed to help designers and developers on their path. Microsoft and Magic Leap, for example, have guidelines relevant to head-mounted displays, and Apple and Google with their ARKit and AR Core for mobile platforms. I highly encourage you to read them, because it's impossible to cover all the aspects in the context of this lecture, but it will be useful for you to know this basis for your future work. I know that we wanted to work previously with head-mounted display initially at the Code Reality School, so I want to mention a few augmented reality guidelines that are relevant to this type of medium. Designing content for augmented reality requires careful consideration of color, lighting, materials for each of the visual assets that are used in your experience. These decisions can be for both aesthetic purposes, like using light and material to set the tone of an immersive environment, and functional purposes, like striking colors to alert users of an impending action. Each of these decisions must be weighted against the opportunities and constraints of your experience's target device. Also, audio is an essential part of design and productivity in augmented reality because sound can increase users' confidence in gestures and voice interaction simply by giving them feedback that some action has already happened and they know that the next action is going to appear next, or guide users to the next steps, for example. Effectively combined augmented objects with real world can also give this sense of audio feedback. And also the low latency head tracking of augmented reality headsets supports the high quality spatial sound. So you can use spatial sound to guide users to, for example, give them directional indicators to look left or right, and also help users to maintain awareness of their real world surroundings. To help with the physical awareness, we need to design one experience for many different spaces. For example, we need to give users a clear understanding of the amount of space they will need to have in order to interact with your application. So, try to think about the spaces where the user are going to use this application. Maybe in a kitchen table or in a football stadium. We need to show them that the ideal conditions for using it are ABC and list them. So you can include preview, for example, preview graphics of how it's going to look, or instructions in the application before they actually start using it. For example, one of the ways how you can introduce this is by visually showing the surface detection, so to see how the application is interacting with your space. So it's very helpful to consider that all spaces that your app might be used, from a small apartment to a vast field, it's important to introduce them. And we need to prepare for large and small spaces, real world obstacles, for example, like furniture or traffic, and also the physical challenges that might occur. So public spaces, they provide their own set of challenges for augmented reality. Tracking and inclusion become really difficult, and depending on the number of objects and people around, it's really hard to predict, but somehow we magically need to consider these things. And also think about the phone movements. Is it safe to use augmented reality in this environment? Is it safe for the user, or this might be really distracting and dangerous? Also, using the surface magnetism technique, like in this example provided by Microsoft, you can place a holographic object on a real world physical surface, and by aligning the object's orientation with the real world surface, you can create a more immersive and natural experience for the user. So it's important to show them how your content is going to interact with their space, because their spaces are private. It's important to introduce this gradually and also explain how it works. In order to explain to your user how something works, we need to introduce interaction model, potentially multimodal interaction. And while we recognize that there are thousands of effective and potentially engaging interaction model possible in augmented reality, we found that intentionally employing a single interaction model end-to-end in your application is the best way to ensure that your users are successful in achieving their goals and also having great experience, because it's really hard to deliver a message using different interaction methods So it's important to communicate that from the beginning of your application. I highly encourage you to follow this link, tiny.cc-multimodal, where you can read more about multimodal interaction and when to use what type of interaction, sort of the guidelines that you might follow. And you should find this useful for your references. But let's just go and discover 3 most common interaction methods. Based on the research and feedback from the users, 3 primary interaction models were determined by the AR community that suit the majority of augmented reality experience. In many ways, the interaction model is the user mental model for how to complete a certain workflow or task. So each of these interaction models are optimized for a set of customer needs and are convenient, powerful, and usable when are used correctly. So the first model is hands-free model. It's used in 3D spatial experience such as spatial layout and design, or content manipulation or simulation when you interacting with digital content. The second model is gaze and commit. It's great for a contextual experience where users' hands are occupied, such as maintenance tasks or on-job learning or training, for example. And the last model is hands and controller. So it's designed for click-through experiences, for example, 3D presentations or demos. And to ensure that there are no gaps in the user interaction experience, it's best to follow the guidance for a single model from the beginning to an end of your AR experience. I've decided to summarize the core concepts of multimodal interaction and interaction with AR in general in this simple 9 points. Let's talk about first 7, and then about the point 8 and 9 we will go in the next slides. So the first one is to ensure that interaction are accessible. So as I mentioned, it's impossible to explain to the user what's happening, how to use the application, and you also need to think about disabled people, so how they're going to access your content. Have you considered accessibility issues? The second point is to make the experience as clean and simple as you can, so without overloading user with any unnecessarily super complicated context or content that's impossible to interpret. Try to make it as simple as the white paper, easy to understand how to use. Point number 3 is to consider lighting and environment and to suggest fixes when problems occur. So it's impossible to predict the actual physical environment of the user, and try to think about the potential cases, as I mentioned before. For example, a bright light coming through the room and the room is overexposed and it's impossible to see the text, for example, on your application. So try to suggest the color changes, for example, or ask user to move the content to a different area if it's too bright or too dark, for example. Point number 4 is onboard the user if required. This should be done in real world space if possible. By this I mean the introduction to the application, so how to use your controls, how to interpret your main interaction methods, and if possible try to introduce them within the room context. For example, use spatial mapping to understand the space and then position some introductory tutorial on the wall. Step number 5, use direct interaction with objects over on-screen controls. So if you have an option to provide users with direct interaction, the interaction with objects, for example, try to avoid different like heads-up displays and controls on the screen. Or it's probably also relevant to mobile phones. Try to use some interaction with physical objects and holograms rather than on-screen buttons that are used to control the content. Step number 6 is keep interactions simple, stupid. Yes, just keep them simple. Choose one interaction model and be consistent in using this model. And step number 7, use the entire display to engage people. It's impossible to use all space around the user since we live in 3D environment and we have this capability of utilizing all the space. We need to be as inventive as possible to use the space around the user, but also try to be safe, reasonably safe. Don't ask people to cross roads or run somewhere. At some point, I think that Pokemon Go is quite a dangerous game, actually. And with the next point, we're just going to jump further. For example, that's my favorite one, is use it for a reason. And that's reason being that experience can only be achieved through augmented reality. For example, this shopping experience. Okay, so imagine you're going to the store and you need to find something that you don't understand. For example, you have recently moved to a new town, you don't know how to use the system, and you want to create a shopping list, an ingredient list, and that helps the user to quickly determine what that is. But at some point, this application is a single-use application because, okay, how often are you going to explore what are the ingredients on the shelves, because we are spatial creatures and we easily memorize what's located in space. So it's really hard to imagine a situation when you struggle to remember where the pack of tomatoes is located in the store. But think about the multi-use of this application. For example, people who are coming from different countries, for example, you're visiting Japan and you're struggling to understand. Well, I hope that this picture of the Japanese store is actually a store. I was really struggling to translate it. But that's an example. You have problems translating, you have these barriers. And introducing your application for the multi-use in different countries, for example, or in different stores might help to increase the use, first of all, but also increase the usefulness, because different people will have access to this application and it will be used in different language contexts, for example. And the next bit is always give a feedback. This is also one of the biggest problems that people encounter in augmented reality. They don't know what's happening. As 2D space, in working in 2D space, we're quite used to seeing these progress indicators, these bars, when we're loading a website, for example, or downloading something from the internet. We know that something is happening and the system tells us what's happening. In augmented reality, in 3D space, sometimes it might be really, really hard to understand what's going on. So try to give those indications that the feedback is happening, that something's going to happen next. And since we have this magical use of 3D space, try to use this space as a placement, as a placeholder for this feedback cues. It's important to give constant feedback cues, because otherwise the person will be simply lost in the experience. Now let's have a look at some of the examples of augmented reality applications. I quite admire the idea of using real world as a reference for our design decisions, and also basically to use real life as an inspiration for problem solving solutions. For example, this first case is a well-known IKEA application. So I'm just thinking about the struggle of buying a sofa, for example. It's quite bulky and I don't know how it looks, whether it's going to fit my room. So instead of ordering one and returning back to the store, I can simply use this preview application and see how it looks. There are some downsides for this because you can use it only once. I'm not sure how often people are buying new sofas or new furniture in general, but for a company, it's quite beneficial because you can increase sales and reduce cost you spend on delivering and returning items. The next example is also a home example. It's an application that shows you the colors of the walls. So you can scan your room and you can pick a color and paint different walls in different colors. So if you have this experience of doing renovations, you might have considered using this application actually, because it's quite useful and easy to use. This solution also inspired by real problems of this test patches on the walls and then the general struggle of repainting them and covering with the color that you actually decided to go for. So I admire this idea of live problems as an inspiration for solutions. Or this Airbnb manual example, it's basically an application that transforms paper instructions into physical notes. You can use this application to annotate all the important elements, sort of the key points in your house to help the host to find relevant information. For example, how to turn on the heating, how to fix the radiator, or where to find towels. So this content is interactable, and you can use this as a reference points for your hosts to find info, thus making it more easy to find, easy to use, and also you can ask live questions. You can record videos and communicate with the host in this easy manner. So this is also something that was probably inspired by the struggle of using Airbnb service across the world. But we need to be reasonably inspired, I think, because this concept of Keiichi Matsuda, the hyper reality with a lot of superimposed information that are basically making user to feel quite overwhelmed about the content. It was maybe also inspired by all the advertisement that we see, all the notes and posts that's impossible to read. Try to be reasonably inspired and keep it simple, as I mentioned before. So before we finish this part of the lecture, I want to mention a couple of user interface pain points that you might encounter on your augmented reality journey. So the first one is the limited field of view and the controllers. So as you know, in most of the AR headsets and mobile phones, definitely the field of view is quite limited, even though it's getting bigger and bigger with time. It's sometimes really hard to understand the mapping between the controller's view and how it works with the field of view. So you might think about that point when you're using controllers, and also thinking about methods of simplifying that interaction. For example, raycasting and transmitting the endpoint of the controller to the actual object. So helping user to understand how the controllers work with the limited field of view. The second point is so-called near clipping plane. This basically means that when something gets closer than about 40-50 centimeters to the headset, it disappears. And that happens, and we need to wait and see what will happen next. But currently it's working like this. So try to use content that's not that super close to the user, and maybe limit the size of the element. Make it smaller if it's possible. And the third point that we repeatedly see that users being so in awe of augmented reality to the point that they're actually really engaged and their attention is completely captivated by the visual and interactive elements of that experience. So attention is really a limited resource, and it's a key to orchestrate the different stimuli so that important information is not missed by the user. And applications that rely on voiceover to onboard users and provide critical instructions can fail sometimes because they deliver audio information at the wrong time, often too early, or when the user is still engaged and exploring the environment. So perhaps the most important technique to remember is to encourage movement and exploration within the application, is to let users adjust to that experience. Try to give users a short period of task-free time with that device, whether it's a head-mounted display or mobile phone. This can be as simple as placing an object in the space and letting just users to move around this object, and narrating an introduction to that experience, for example. This time should be free of any critical tasks and specific gestures, such as air tapping or dragging, and try to instead initiate that purpose, to let users accommodate to viewing that content through the device before requiring any interactivity or progressing through the different stages of your application. So if this is a user's first time with the device, this is especially important as they get comfortable seeing content through the holographic frame and explore the nature of the holograms.